Continuing with complex numbers, we'll talk about multiplication of complex numbers. So if you have two complex numbers of this form, a plus bi, you can actually just multiply them the way you multiply binomials, by FOIL method. So I can just take the 4 times the 2 and get 8, and then the outer product would be 4 times 3i, which is 12i. The inner product would be minus 7i times 2, which is minus 14i. And then the last product, minus 7i times 3i, would give me minus 21i squared. Now, one thing you have to remember, that I squared always equals negative 1. So we're going to replace that I squared there with negative 1. Now, I can combine the 12i and minus 14i and get minus 2i. And then I just bring the 8 down. Now, but when I change the I squared to negative 1, then I'm going to have negative 21 times negative 1, which is going to be plus 21. And I can add that 21 to the 8. And see that 8 plus 21 is 29. And then just bring down my minus 2i, and I have my answer is 29 minus 2i. Now, if you just have the I portion multiplied by a complex number of the form a plus bi, then you can just distribute. So here I'll multiply negative 7i times 5, and that'll give me negative 35i. And then negative 7i times 3i will give me plus 21i squared. Now, I'm going to write this term first, because this is actually going to turn out to be the real portion, because I squared is going to be just negative 1. So I'm going to have 21 times negative 1. And then I can write the minus 35i after it. Now, 21 times negative 1 is just negative 21. So I have negative 21 minus 35i. Now, on this one, before I do anything, I want to simplify these radicals. So I can actually take, I can't really do anything with the numbers in these radicals, but I can take care of this minus that's in this radical and this radical. So we know the square root of negative 3 is just I times the square root of positive 3. And we know the square root of negative 6 is just I times the square root of positive 6. So now let's do the FOIL method. So if I multiply the first term times the first term, so that's square root of 2 times square root of 5, that'll give me square root of 10. And then if I multiply the outer terms, I'll get square root of 2 times square root of 6, which is square root of 12, and then of course times I. And then if I multiply the inner terms, I'll get square root of 3 times square root of 5, and of course I also have I, so that's going to be square root of 15i. And then if you multiply the two last terms together, you're actually going to get minus I times I, which is going to give me minus I squared. And then you also have square root of 3 times square root of 6, which is square root of 18. Now, a couple of these radicals I can simplify, because square root of 12 I can write as 4 times 3. So that I can write that as square root of 4 times 3. And then square root of 18 I can write as square root of 9 times 2. And then I have the square root of 4 is 2. So this would be 2i square root of 3. So I'm going to put that, the 2 square root of 3, I'm going to put right here. And then this is square root of 15 times I, so I'm going to put that together right there. So what I'm doing is I'm combining my two terms that have I in them. So this would be 2i square root of 3, and this would be minus I times square root of 15, but if you factor the I out, then you just get 2 square root of 3 minus square root of 15 times I. And then the terms that don't have the I with them, the square root of 10, bring it down, and then this is a minus, so it's going to be plus, and then take the square root of 9 out, so you'll get plus 3 times square root of 2. So I kind of shortcutted that step. I probably could have put a step in between there, but basically what I'm doing is I'm combining these terms to get the last expression, and then I'm combining the first and last term to get these two terms. So anyway, that you can't really write it in the form a plus bi like you could here, 2 plus 3i, but actually this sum right here is your a, and this difference right here is your b. So we really do have a here plus b times I. Okay, now on this one, the mistake folks will make here is they will just multiply this together and get square root of 100, but that would be the wrong answer, because first thing you have to do is rewrite these by taking the I out of the radical. So square root of negative 5 is I times square root of 5. Square root of negative 20 is I times square root of 20. And then when you multiply these together, I times I is I squared. And square root of 5 times square root of 20. Now you can multiply that together and get square root of 100. But then I squared is negative 1, and square root of 100 is 10. So you actually get minus 1 times 10. So your answer is minus 10. Now this we're going to need in the next section. And these are actually called complex conjugates. And so anytime you have a minus bi and you multiply it by a plus bi, what it does is it eliminates the imaginary number. And let me show you what happens. You remember when you multiply numbers, when you multiply binomials where the only difference is the sign between the terms, then you can use the difference of squares formula. So using the difference of squares formula, 5 minus 3i times 5 plus 3i would simply be the 5 squared minus the 3i quantity squared. And then 5 squared is 25. And then when you square 3i, you get 9i squared. And then remember, I squared is negative 1. So actually this just turns out to be a real number. Negative 9 times negative 1 is plus 9. So you get 25 plus 9 is 34. And see, so there's no more I in the answer. And that's always the case when you multiply two complex conjugates together. And we're going to need that in the next section, which has to do with division of complex numbers.